All right, welcome everyone to the Xojo webinar. I am Paul Lefevre, the Xojo Developer Evangelist. And our topic this time is connecting to databases. I get a lot of questions from people from time to time asking some somewhat basic questions about how to connect to a database. And that varies a little bit depending on the type of app you're making. So I thought it would be worth having a webinar to kind of go through the different app types and the ways that you would connect to a database in those app types. Now, we're going to go into a lot of detail about database here. I'm mostly just going to focus on the connection aspect and answer any questions that come up. So let's get started. So first of all, I like to reiterate what databases Xojo supports. And there are quite a few. And it's the same set. It's been around for a while. SQLite, obviously, very popular database. Has a lot of uses. I think pretty much anyone that's ever used Xojo has probably used SQLite in some manner or another. There is Postgres Sql. This is also another very popular database. This is open source. This one is extremely popular because it also has no unusual licensing or anything associated with it. It's just free to use. Unfortunately, it's not often pre-installed on some servers as much as the next one, MySQL, which is also another open source database that is also very, very popular, more popular than PostgreSQL, definitely. It has some strange licensing things that might make it inappropriate for your types of apps, but it's a pretty solid database regardless. Then, of course, there's Oracle. That is a database that's really used by large enterprise type development shops. Oracle can be pretty expensive, although I do believe they have some sort of express or free version that's available for use. And then also kind of its companion in the enterprise market is Microsoft SQL Server, which is also a large enterprise type database, often used by enterprise companies and can get a little pricey. And then Odbc is not really a database per se. It is a database connection standard, but it can be used to connect to just about any other database that's not on this list. So all you need is an Odbc driver, as they're called. You can install that on your operating system, and then you can use Odbc to connect to the database. So that's what databases are supported by Xojo. Now, of those, they can all be kind of grouped into two types of databases. There is SQLite, and there is everything else. And I say that because SQLite is what's called an embedded database. It's file-based. The database engine is actually included in your app. There's not a separate database engine. There's not a separate database server or anything like that. So it's kind of its own thing. But all the other databases are actually database servers, which means the database itself has to be installed separately from your app and has to run somewhere. And generally, it does not run on your own computer. It runs on a server somewhere, another server within your company, another server that's on the internet somewhere, but it has to be a server somewhere. And of course, it is possible in your own testing and all that stuff to have the database server running on your computer. Of course, that works just fine. But when things are put into production, these are almost always separate things. Now, what we're going to look at here in some of our examples is I'm going to use the Eddy's Electronics database. This is included with Xojo. It's a pre-built SQLite database. You can find it in your examples folder in the sample applications folder, and then in there is the Eddy's Electronics folder. And in there, there's a database folder that has an Eddy's Electronics.SQLite file. That's what I'll be using, although this one is slightly updated with some more sample data than the one that is included in the most recent version of Xojo. Oh, and there's the path for it. Another database that can be good to play with when you are just want to kind of test out things. So sometimes you may want to test out, how to design your app without having to, create a full-blown database and populate it with data. And there's an open source database called the Chinook Database, which you can grab at that website. And that's available in a wide variety of formats, pretty much for all the databases I listed that Xojo supports and many others as well. And it's pre-populated. It's trying to remember what's actually in the database. I think it's like music artists and stuff like that. But it doesn't really matter what's in the database as long as it comes pre-built with a bunch of tables and a bunch of sample data that you can query and add to and join the tables together and all that sort of stuff. So we're not going to look at Chinook Database today, although I have played with it in the past, and it's pretty neat one to play around with when you're testing things. And I'll probably at some point be building something in Xojo for an example that uses the Chinook database a little more extensively. Now let's first talk about desktop SQLite. Now, of course, maybe not of course, not everyone always understands this, but SQLite is single user. And that's pretty typical with a desktop app. I mean, you only have one user using your specific desktop app. But you're not generally going to have multiple desktop apps connecting to the same SQLite database. That really doesn't work well. Technically, you could do it by taking your SQLite database, putting it up on a network file share volume or something like that, and pointing your desktop apps to it. But that is probably going to result in tears. SQLite is really not designed for that. The performance is going to be abysmal, and that would be the best case situation. The worst case is that somehow your database gets corrupted because network file locking may not work so well with the way SQLite is implemented. We have a lot of warnings about this on the official SQLite page, and generally we try to discourage people from using SQLite in that manner. All right, I'm seeing a couple questions come up, and one of them had a raise the hand thing. To be perfectly honest, I don't really know how that works in Zoom. So if you have a question, just type it into the Q&A window, and that will pop up on my screen, and I'll see it. All right, so let's chug through the next thing. So generally speaking, your desktop is going to have just a single connection to your SQLite database. Now, there are exceptions to that, of course, but generally speaking, you're just going to need a single connection, and your app will be able to talk through that connection. That relates somewhat to a question here that Edwin is asking. Are multiple processes within a single app, would that mess up the single user concept? And no, it won't mess up the single user concept. Technically, there can be multiple connections to a SQLite database. The problem with the multiple users to a SQLite database is simply when the database itself, the database file, is sitting on a network share. But if multiple apps that are on the same computer are talking to the same file that's also on the computer, that works, as we'll see when we talk about web apps. Again, generally speaking, in a desktop app that's using SQLite, you're going to want to connect to the database when your app launches, probably right in the open event of the app object. Now, this is an important one. Newer operating systems tend to prefer where files are placed because they're starting to mark certain areas of the drive as read-only. And we'll often run into people that will try to put their SQLite database right alongside the app. And that's going to be a bad idea because often the app folder is read-only. So you're going to end up with your app not working quite right when lots of database errors are being raised because you can't change the file that's sitting next to the app. So generally speaking, you want to put the database file in a place that is recommended for these sort of files. And you can use the Xojo special folder. I guess it's a module technically. And you can access the application data part of it to get the location on the file system, and that varies by operating system, of course, for where you're going to want to put the database. So special folder.application data will give you that. And on OS 10, that is the application support folder for the user. And on Windows, I think it's actually called app data. Unfortunately, on Windows, the folder is hidden by default, which is a little annoying if when you're developing, if you want to go in there and look at stuff. But you can easily go into Windows Explorer and uncheck that and make it visible so that you can see the database, see that everything's created, that sort of thing. On Linux, I'm not exactly sure what that points to. It's going to vary depending on the Linux distribution. It's possible it'll just point to the main user folder. All right, now We're moving on to database server. I'm just giving high levels now. We're going to jump into Xojo in a bit and actually look at code for each of these types of things, so you can see what the code looks like. We'll run them, and you'll see how it's connecting to each of the databases. But this is a high level to give you an idea of the concepts. And before I get too far off from SQLite, Edwin is asking, do you have to check the connection every time you request data from a SQLite database? I didn't mention that on the desktop SQLite one, because generally with the desktop one, no, you don't need to bother. But that'll come up here when we talk about some of the other ones. So desktop app talking to a database server. Well, that is where you get multi-user. You can have multiple installations of your desktop app talking to the database, multiple people connected to the database all at once, and it'll all work just fine. That's what those databases are designed to do. That is generally described as what is called a two-tier or client-server architecture. The client would be your desktop app. The server would be the database itself. It's pretty common, simple app designs, easy for people to understand. It's commonly used. Now, it's important to note that connections can drop. So your desktop app's connecting to a database server that's elsewhere. And it's possible the connection can go away. Why can it go away? Well, it can go away for lots of reasons. Bad networks is probably the most common, but I mean, things like the database server could actually go offline. That'll make the connection drop for certain. And depending on where the database server is, that can make these sort of connections dropping become more problematic. This is why we generally don't recommend that you're doing a client server to database server app directly over the internet. Internet traffic is notoriously unreliable. And if you are doing this, it's possible that your connection to your database could fail. And it could fail not because the database server went down, it just could have failed because the internet traffic got a little flaky for a moment. I see that all the time when I'm doing these webinars. I'll get a little message that pops up that says, your internet connection is not entirely stable. Or something along those lines. I think that might have been a Star Wars quote. But things like that happen on the internet, and that's generally bad news for a database connection because it'll just get dropped. And if your app is not designed to take into account the possibility that your database connection could go away, it might just crash. And that's not really a great user experience. And I didn't mention it on the SQLite one. Obviously, transactions are always a good thing to use in general. But when you're dealing with something like a database server, using transactions is absolutely critical. And this is because of the multi-user aspect. Now, a transaction allows you to have a set of database instructions kind of happen as a block. And then if those block of things succeed, then they all get permanently committed, as it's called, to the database. But if there's a failure of some kind, then none of the block is committed to the database, and it's as if it didn't happen. Now, in general, that's good just for database integrity, but it's particularly important when you're dealing with multiple users because you may not want some data to become visible to other users until the block of operations is done. So that's one big reason to do it. And the other big reason is just generally speaking, again, database servers often deal with larger volumes of data, and transactions can help with that as well. So you really are always going to want to use transactions when you're dealing with a database server. And prepared statements. Now, you don't really 100% need to use prepared statements with a desktop app, but you probably should. And there's a couple good reasons. The obvious good reason to use prepared statements is for the SQL injection possibility. And with desktop app, again, that's never been as big a concern as it is with web apps, but it is a concern and something to think about and maybe take into account. But the other reason to use prepared statements, particularly with a database server, is that the server itself will essentially pre-compile the statements and keep these things in its memory. And this can lead to some subtle performance improvements depending on the complexity of your SQL, so that the statement doesn't have to be essentially rebuilt and internally recompiled from scratch every time. So you get a little bit of a performance benefit there. And you just start to get into the good habit of it, so that when you do switch to web apps where SQL injection is much more of a risk, then you already are familiar with how they work and kind of using them as old hat. All right, moving on to web app. A web app that uses SQLite. Now, this is a little bit different than a desktop app in that web apps can support multiple users, right? Multiple people can connect to a web app. Well, I said before that SQLite can't support multiple users. So how is these two things compatible? Well, they're compatible because SQLite, from its perspective, only has one user, and that user is the web app. So only the web app is talking to the SQLite database. Nothing else is talking to the SQLite database. Sure, the SQLite, the web app is handling a bunch of different users, but they're all going through a single app, the web app, and that is handling all the communications with SQLite. So that works fine. Of course, you're probably going to want to stick to low, medium volumes for that. I mean, SQLite still is not a full-blown database server. If you're doing a ton of writing, things are going to have to wait for writes to finish. And that could start to impact the speed of your web app. So, again, like anything else, you have to pick the appropriate tool that's going to match the type of app you're building. But SQLite can certainly work for a lot of web app types. Now, the important thing to understand with SQLite, though, is that you're going to want to create a separate connection to the SQLite database for each session that connects to the web app. Now, this is different than a desktop app. In a desktop app, we were creating a single session right when the app opened, and we were using that pretty much throughout the app. That's great. But on web, you really don't want to do that. Now, you could do that, but you really don't want to do that. So instead, you're going to create a new connection to the database each time a new session is created. And there happens to be a session.open event that is called whenever a new session is created. So you can do your connection right in there, save the connection, and use it throughout that session. And when that session goes away, you can get rid of the connection. All hunky-dory. Now, there are maybe, and now before I go into why you might want to do it the other way, why do you want to do it this way? Well, again, the big thing is transactions. You really don't want two different users to see data that they shouldn't be seeing. And you're also going to want to have transaction management be by user. So if I have two people connected to my website, I want to be able to have each of those people have their own transactions so that their data is committed in their own blocks. And if there's a failure, only their data is not committed. If it's a success, only their data is committed. So everything's nicely isolated. If you tried to use a single database connection for your entire web app and all the sessions, you could run into situations where some data might be committed, some data might not be committed, depending on your error handling is implemented. But either way, you're going to have a bad time. Now, there is probably a special case where having a global connection to the SQLite database in a web app would make sense. And that would be if it's really just read-only. You're just reading from the database. You're never doing any writing. And if you're just doing that, then global app property SQLite connection, I think that would probably work okay. Now, there's a feature on the SQLite class. I think the property is called multi-user, but it actually enables a feature of SQLite called write-ahead logging. And this changes how new data is written to the SQLite database file. Now, normally, when you're adding new data to SQLite, the data is just essentially appended to this main SQLite file, and then a companion rollback file is created that contains the old data. And if it turns out you need to roll back, then the new data is removed and the old data is put back. And that can work great for a lot of situations, but it does always result in 2 disk writes when you're adding data to the database. And that can be slower. So with write-ahead logging, it kind of flips that a little bit. and instead writes new data to a separate file and just writes it. And then periodically updates the main database file with the new data that's in this essentially write-ahead log file. So the long and short of it is that writing is quicker when write-ahead logging is enabled. And you're going to want writing to be quicker when, in particular, you have multiple web users talking to the SQLite database. So that's why you want to turn this on. You can even turn it on for desktop apps, of course. You probably just would want to test your desktop app to see if that's really giving you any performance improvement. It may not, but that's what that feature does. I mentioned transactions earlier. Here it is actually in the bullet point list, but I don't really need to rehash that. But transactions are obviously important when you're dealing with multiple connections. Prepared statements. Well, I talked about those before. The same benefits apply here as well. I've not noticed that caching of SQLite prepared statements is a thing. It doesn't seem like you get any performance improvement out of that aspect of it, at least with SQLite. But however, you do get the SQL injection protection by using prepared statements. And so people have asked me before too, what if I use the record set, edit, and update and the database record classes? Do I need to worry about prepared statements, or do I have to like toss all that out and start to use the prepared the specific prepared classes for the various databases? And no, the answer is if you're using the record set updates or the insert table stuff, that kind of already does the prepared statements behind the scenes. So you're already good. But if you're using direct SQL, writing update or insert statements, select queries, certainly you're going to need it with select queries. That's where you're really going to want to be taking advantage of prepared statements so that you don't end up with SQL injection issues. All right, let's see. Edwin is asking a question related to prepared statements. And his question is something about changing the binds every time you want to use a particular statement. Yeah, and I'm not entirely sure. That's probably going to vary depending on the database server. I would expect that the binding is part of the compilation process, but maybe not. So I'm afraid I don't really know the answer to that one. All right, now a web app talking to a database server. Certainly a situation you might want, because like I said, SQLite, although it can work for a lot of things, is not going to work for every type of web app. And if you have a lot of database activity going on, a lot of writing, you're probably going to want a specific database server in addition to the web app itself. Now, there's a couple ways you could have that implemented. You could put the database server right on the same server as the web app, right? So you could have essentially a single physical server that's running a web server and running a database server. That obviously will work perfectly fine. You just need to make sure the hardware configuration is up to the task, but that will work perfectly fine. That has the great benefit of being very secure, because everything, the communication between the web app and the database server is all local. There's no way for anyone to directly communicate with the database server, and that is very, very nice for security. But you may also need to have a separate server. And this could be, if you want to have a specific piece of hardware that is highly tuned and performance optimized for a database server, and have another one that's for your web server. Perfectly fine setup as well. Sometimes you'll see this with companies that have, database administrators on hand, and they're the ones in charge of the database servers, and they don't know anything about the web servers. So these things are all isolated amongst departments or things like that. If you do have this particular setup, again, if both these servers are local to the infrastructure that's kind of back there, then the communication between the web server and the database server is essentially over the local network, in the data center or wherever. And that, again, is nice and secure. But there is a risk if your database server is publicly available on the internet and you're connecting to it in that way, because that essentially means someone, and apparently there's nefarious people out there that do these sort of things, will sniff around and see if there's ways to get into this database that's exposed in this manner. So if you do set up your structure like that, you'll need to pay very, very close attention to security. Now, again, you're going to want to do one connection per session for the same reasons as SQLite, data isolation primarily being the main reason. Again, transactions with a server, incredibly important. There's no reason not to use them. Really, the only time transactions are optional, in my opinion, is if you're using a desktop SQLite app. You can kind of get away maybe with not using them, but otherwise, I think you're going to have to use them. And of course, prepared statements, like I talked about. You want to take advantage of these. All right, the last type of connection you can do here is having an iOS app that can connect to SQLite. Now, iOS apps, very focused apps, run on a device. They just have a single connection to SQLite. So again, in that manner, somewhat similar to a desktop app that's connecting to SQLite. From what I've seen, most people are putting the database in the documents folder. And this documents folder is the way iOS apps are made. Each app has its own documents folder. So another app that's on the device will not be able to see the database or access anything in the documents folder. One cool thing about putting it in the documents folder is there is a way in iTunes, in conjunction with a plist setting you can put in your app, to make this file essentially show up in iTunes as I forget the term, but it's a shared file that you could then download right out of iTunes and get access to, which might be handy for testing purposes. Generally, you want to connect to the SQLite database right at app launch, just like with a desktop app. Oh, that's the only 3 I had there for iOS. So iOS is going to be very similar to desktop from that perspective. It uses a different class, though, than you use for desktop or web apps. It's still called SQLite Database, but it is a different class. It's part of the iOS framework. So its methods and things are a little different. One of the things that is different is error handling. And I'm just going to touch on that before we jump in and look at some code. So for the main database classes, there are 2 things that will help you track your errors. There's an error property and an error message property. Error is just a Boolean, and error message contains text about an error should the error property be true. Generally speaking, you want to check the error property after every database command to see if an error occurred. This is, you want to do it after a select to see, if there was an error with your select statement. It's possible there's a typo in there or something that could have caused an error. So you want to check for that. You'll want to check the error after, making any changes to the database. You always want to check error. And you want to do this so you're told about the error right away. You don't want to have what was a database error manifest itself somewhere else in your app and kind of throw you off the track of finding your bug, because it ended up triggering an exception in a completely unrelated part of your code. You don't want to see that. So generally, you just check if error is true, and if it is, log or display the error message and kind of stop what you're doing. On the iOS side, instead of checking these 2 properties, there is an exception that is raised if there's a problem with the SQL command that was sent to the server. So you can just wrap your code in the try catch and then check the exception. So a little different, but perhaps a little easier. All right, let's switch over to Xojo. All right, now what I'm going to go through here, again, I'm focused only on the connection stuff. I'm not going to be covering today anything about transactions or prepared statements or anything like that. We're just talking about connections, because we've got a few different types of databases to deal with. But if there's interest, let me know. We can do other webinars on other aspects of SQL and databases in general. All right, so here, first thing I need to do is see. All right, I got to move the toolbar out of my way so I can actually see the top of my screen. All right, so here I have the desktop SQLite project. So this project, so I'm just going to run it. Only purpose in life is to connect to a SQLite database. It's only quickly throwing up some of the data into a list box here so that we can verify that it connected. Can't really do anything with that, and that's not the point. So the point in this one is the connecting to the database. Now, the way I have this structured here is the first thing you can see is I have a copy file step that is copying the Eddie's Electronics database, and it is copying it to the resources folder. This means it's going to be included in the app when I build the app, or when I run it for that matter. This can be a great way to distribute your initial version of your database, copy it right along into the app itself. And then when the app starts up, the open event is called. And here I have a couple methods set up. And I'm calling a setup database file method, which is going to, well, we'll look at that in a minute, but it's going to essentially go into that resources folder, find the database, copy it to where it should be in the user's file system. And then if that all works correctly, it's going to attempt to connect to the database. So if we look at setup database file, you can see here, it's kind of boilerplate code. It looks like a lot of code, but it's not really a lot of code, just a few steps that describe what I said. And first of all, we're going to check our final location for where we want the database. And I mentioned before that you generally want the database in the system folder where you can put data. And you can get that with special folder application data. So in that system folder, I'm creating my own folder, which I'm calling here, this one, webinar DB connection. And within that folder, my folder, I'm putting the database file. So the first thing I do is I check that folder to see if the database file is already there. Because if it's there, I don't want to keep copying my database over and possibly clobbering any data the user has since added to the database. So if it's already there, I'm good. I don't need to do any steps. So essentially, this code only runs the first time you run the app. But if the database does not already exist in that folder, then essentially we just get a reference to it in the resources folder of the app. And that's using this method here. And then it creates the appropriate folder where it needs to put it. And then it copies it. And that's it. It returns a reference to it either way. So that's really all this code is doing here. Kind of boilerplate code. I use variations of this code in lots of different apps. And you can see the open event. That's where this is here. And then the end result is it should have a reference to an actual database, an actual SQLite database file that it can use. And then it can call connect to database, which is the pretty standard stuff here. Create a new instance, assign the file, and then connect. Now you notice I have here DB. This is just a property of app. And I often will just use the name DB like that. And that is it. Now I have a global connection to the database. And I can use it anywhere in my app. So if you look at the code on the window that's populating the list box, I just refer to the database like that, app.db, app.db. So everywhere I have app.db. Now you can set that up, of course, however you want. Maybe you hate typing app.db. You'd rather it was just a global name called DB. Well, then create a module and make DB global, and you can put that on it. You can do it that way. Whatever works for you. But that's generally what you're going to need to do here on the SQLite side. It's pretty simple. Once you have your connection, you're good with it. When your app quits, the connection is automatically going to close. You could manually close it if you wanted. But that's really it. So connecting to SQLite from desktop is really one of the simpler or simplest situations. All right, so see, I got a question here from Vince asking, what if a user wants to put the database in a directory of their choice? Yeah, absolutely. If you're prompting the user and your database is more of a document of your app rather than a behind the scenes kind of thing, then you could certainly prompt the user for a location and then use that location to save the database file. They may pick something in their documents folder or whatnot. And that's absolutely valid. But in that case, you're using a database more like a document rather than kind of a behind-the-scenes storage of information. You don't want to be directly storing stuff in the user's documents folder, though, for example, unless you've prompted them and have their permission. All right, I just need to mark a couple questions here. My list is getting long. All right, so that is the desktop SQLite example. So let's take a look at desktop Postgres. So here is the Postgres example. You see it's not going to do anything fancy again, just the same sort of thing. But the connection's a little bit different. So I still have a DB property that I'm using here. But there's now a database connect method. And connecting to a database server requires a bit more information. You have to tell it where the server's hosted. Odds are you need to provide port information, database information, and login information. So in this particular case, I'm going to be connecting to a Postgres SQL database that actually is running on Xojo Cloud. And you'll notice it says localhost here, and this is because the Xojo Cloud database servers are not publicly accessible. They are accessible on the server, but Xojo Cloud does provide what's called a tunnel, and I can open a tunnel up here on my computer that will essentially provide access to me and only me to this database server, and I can treat it as if it were local to my machine. So that is pretty handy, actually. It still has the downside, though, of I am having a desktop app that's connecting to a database server across the internet. And generally speaking, you know, that, like I mentioned before, that's not the best design for you to choose. But this is an example just to show how that sort of thing might work. Typically, localhost might be the name of another server within your local network that you have the database server running on. And again, you can see here the connection, you know, pretty straightforward stuff here. Usage, again, is very similar to how it was with SQLite. Important thing to point out is the error checking that you want to be doing. Now, I mentioned that database connections can go down. So that is something you're going to want to check often when you have code that's connecting to a database server. So you probably are going to want to be checking if the database has gotten nil. It's possible it just may time out and there'll be an error of some sort, and you'll need to account for that. And what you do in that situation is going to vary depending on your app, though. It's possible that you may be able to just try and reconnect, and all may be good. And you can just continue along your merry way and say, oh, that must have been some sort of hiccup, and all is good now, and I can continue. It's possible you may want to terminate the app. Again, up to you on the app design. But you're going to want to be cognizant of that and be checking for it. You can't just assume that once you've got a connection to a server that thing is always going to be there. It could really go away on you and cause a whole host of problems. All right, so that is desktop with Postgres. Now let's look at Web SQLite. Now, again, Web SQLite, we'll run it real quick. Same sort of thing, list box populated with data from the database. So you see, I don't have any code on the app. No code here, but the session has some code on it. And you can see this code looks almost exactly like the code that was on the desktop's open event, or app.open event handler. And essentially, I'm getting a reference to the database file, and then I'm attempting to connect to it. And if there was any sort of problem, I'm throwing up another page that says there's an error. Now, in the case of a web app, You don't want to be too specific about the error. You don't want to be giving, possible hacker types specific details of what went wrong with your connection. I see that sometimes from time to time on a website. You'll go there and it'll be some sort of database error, and you'll get back information about the SQL statement that failed or something like that. And you really do not want to be displaying that information. So in my case, this error page just says could not connect. What you probably want to do in this case is be logging that information somewhere in a file that the administrator has access to so they can figure out what went wrong. But just displaying that publicly is a bad idea. Again, I have database property. Now here I have a simpler structure. You can see here on my copy file step, I'm just copying the Eddie's Electronics database over right alongside the app itself. I'm not putting it in a special place. And that's because this is a web app. This thing's deployed on a web server. And I have some control over how I configure where it's deployed to and the permissions and all that stuff. So here I just said, well, you know what? I'm just going to stick this right alongside the app. It's possible you may want to put it in a different place on the web server. And if so, just note where that place is and then change your connection code to where it is and connect to it. Important thing here is the multi-user property is set to true to enable the write-ahead logging. Other than that, the connection stuff is the same. Yeah, as you can see, the setup code just gets a pointer to the file that was copied over. It's not doing any further copying or anything like that. And you can see the code here. This code is pretty much the same across all the examples. It's just requesting information. Now, I'm not using prepared statements here because there is no user input. So it's just my own SQL statement, so it can't be compromised. But if I were accepting user input, to search for a customer name or something like that, then that's the case where you definitely want to be using prepared SQL statements. All right, I have a question here from Burkhard that is asking, is it possible to connect a web app using Postgres SQL? Well, luckily, that's my next example. So let's open that one. So yes, absolutely, you can connect a web app to Postgres or MySQL or anything else. I'm just doing Postgres here. And again, you can see, actually, let's just run this. So I run it here. It's doing the same thing as the desktop app was. It's actually, it's running the web app locally, and then it's going through my tunnel over to the Postgres database that's running on Xojo Cloud. I'll also deploy this directly to Xojo Cloud. You should be able to see that running that way as well. So connection stuff. Again, on the session, you're going to have your open event handler and just need to connect. So, in this case, the database, this is the situation where the database server and the web server are on the same machine. So localhost is used as the host because they're both on the same computer. Whether the web app is running in the cloud or on my computer, they're on the same computer. And then you just provide the same information you provide with the desktop app. No difference there. And the important thing is you're creating a new connection by session. And as you can see, the loading code exactly the same again. No real difference there. And as you saw when I ran that, it connected to the Postgres database that's on the server. I can try doing the deploy here. Might take a little bit, a few seconds to upload that to Xojo Cloud, but while we're waiting for it to do that, let me scan questions. All right, so Burkhard had asked if we can connect to PostgreSQL, and yes, absolutely. Darren is asking if it's possible to download the SQLite database from a web app to use locally in the browser local storage. I'm not aware that Xojo has a way to do that. I'm not familiar with browser local storage, but certainly Xojo doesn't have any built-in capability to access that. And at this point, all SQLite access through Xojo web apps is through its own database classes, which doesn't involve browser local storage in any manner. The SQLite database would have to be on the server alongside the web app. But that seems like a great question, this browser local storage thing, a great question to ask on the forum to see if there's people that have perhaps played with that, to see if that's maybe something that can be implemented using the Web SDK or some other means, should you need that capability. All right, here we can see the web app just launched on Xojo Cloud and connected to the Postgres SQL server and pulled in our sample data. So all just works great. And that is one benefit, of course, of having Xojo Cloud, is you don't have to worry about configuring Postgres or MySQL for that matter. It's all there. You just have to click a button to turn it on. And then connecting to it is the same as if you had it installed locally on your computer. So your code doesn't even need to change, really. So all nice and easy. All right, let's move on to the last example here, which is the iOS. All right, and let's run that. Want the iOS simulator boot. This will just show a list again of customers from the database. And you can see this code is almost exactly like the database code. I have copy database step here that is just copying this to, where am I copying it to? Oh, that doesn't seem right. It says I'm copying it to the app parent folder. I doubt that would work if I deploy it to a device. I should have made that be the documents folder. Or as Edwin is noting here in a, not really a question, but a comment, he's noting that the caches folder might also be a good place to put your database file because that is handled differently by iOS, might be something that can be cleared. So if your database can be recreated at any point, you know, and if the OS is doing some sort of cleanup thing that I guess it can do from time to time when space gets low, then you'll free up space, and then your app, when the next time it's launched, will recreate the database as needed. So that using the caches folder as well might work. All right, so you can see here, I'm copying, yeah, so it's pretty much doing the same thing as the database one. I'm grabbing the file out of the resources folder for being copied in, and then I'm copying it to documents, and then I just use it. So same sort of thing as the desktop app, but essentially you bundle the database with your iOS app, and then you copy it where it belongs, and then you use it from that point in its new location. You don't want to make a mistake and use it from within the bundle, again, because the bundle will be read-only, and you're going to get errors. I have had a few people email me that kind of missed that step where they had all their code in place and everything, but they forgot to update one little property, and they ended up pointing to the database in its original location in the bundle rather than its copied location, and their apps were crashing weirdly, and they were confused. So something to pay attention to. And you can see the slightly different syntax here with the try catch, looking for an error coming back from the database, and the other slightly different class names. On iOS, it's SQLite record set, not just record set. All right, let's see here. A few questions in the queue, so I'm just going to go through those. All right, Burkhardt is asking, is it possible to connect with a web app to Postgres on the home computer desktop without a VPN? I'm not sure I understand the question. I mean, certainly you can install Postgres anywhere you want, and as long as you can connect to it or access it, you can connect to it, whatever. But I mean, if you're deploying a web app somewhere, that means wherever you're deploying your web app to has to have access to that Postgres SQL server. Generally, the easiest design for most people is to put both the web app and the database server on the same deployed server. All right, Darren is asking, when a web app is connecting to a database, does the client see any connection info? I'm not sure what you mean by the client see any connection info. I mean, the client has to know how to connect to the database, but I mean, seeing it, I mean, from a display standpoint, I mean, the user is only going to see what you're displaying. So I'm not sure what you mean by see connection info there. All right, moving on. Darren's also asking, if you're syncing a SQLite database on an iOS app with a cloud database, can any info be seen when connecting? Again, I'm not entirely sure what is being asked there, Darren, but if you want, feel free to email me with more specifics of what you're trying to do. I'll be happy to spend a little bit more time understanding that, see if I can point you in the right direction. But yeah, I'm not sure what that means at this point. Edwin is asking, do you always have to close a record set to avoid having too many open? And generally speaking, I always close them. I think it's more of a habit. You can see I call the close right here on the record set to close it. But the record sets will close automatically when they go out of scope, which usually is going to happen anyway, because you often have different methods set up to use a record set to pull data back. So closing them is not really a requirement. They'll close when they go out of scope. And second part of his question is, can you check how many connections are being used by the app? No, I don't believe we exposed that. I'm thinking, but I don't think so. I'll have to just do a little double check, see if I'm wrong, but I don't think we expose how many connections are being used. All right, let's go back to our last few slides and wrap up. And let's see here. All right, so what I didn't talk about is the situation where you have an iOS app that communicates with a database server, or a desktop app that communicates with a database server that's on the internet. And that's going to be an upcoming webinar towards the end of March, end of this month. And that is going to be making a database web service. And we're going to talk about how you would create a web service that will, essentially the web service will be responsible for interfacing with the database. So you're going to build a web service that talks to a database. This is the only way on iOS that you can communicate with a server database. iOS is not designed to allow essentially client-server connections like we talked about with the desktop and the web app. So you can't really do that on iOS, but a asynchronous HTTP protocol that's right in iOS's wheelhouse. So you can definitely do that. And it has a lot of benefits as well, because then a lot of tools can now take advantage of your web service and have access to the database in the way you provide. And specifically, we're going to use a new Xojo open source project from Tim Dietrich called Luna that is essentially a framework that'll make it a lot easier to make a web service that connects to your database. So I expect I'll have a web service built that is using the Eddie's Electronics example in some manner or another. I'll probably have a web service made that talks to either SQLite or Postgres. Maybe even you can flip a switch and it'll just pull the data from the appropriate places. And for the examples I showed today, I used the SQLite Eddie's Electronics example that ships with Xojo. I also created a Postgres database containing the Eddie's Electronics data as well. I don't yet have an export of that or anything, but if that's something people want to play around with, just shoot me a note I'll see if I can put something like that together. And then you can have your own version of Eddie's Electronics on Postgres that you can play around with. So email me so I don't forget, because actually I don't know how to do that off the top of my head, and I'll have to look it up. All right, a couple lingering questions, and I think we'll be done here. Edwin's asking about MySQL licensing issues. Yeah, I'm not going to really go into that. That could easily be a couple-hour webinar. MySQL just has lots of licensing and lots of confusion around their licensing, so you should go read it and see if it scares you, or if you think, oh, I'm fine, I don't need to worry about it. But that's kind of my take on MySQL. And then just in general, is it possible to switch between databases? And yes, absolutely, you can switch between databases. Of course, it probably means you might have a little work for you, depending on your code. But I mean, switching from a Xojo standpoint just involves changing your class. So you'll notice if, let me see if I can switch here. When you look at, I'll go to one of these other ones. So if you look at the desktop SQL, I've got the DB property declared here as SQLite database. I mean, I could just change that to Postgres and then go through the hoops to the other things, and then my code by and large will work. But you are going to run into possible situations where SQL is different. Particular SQLite, it has often simpler versions of selects that it can do versus other databases, and same thing with alter tables and things like that. So you'll need to review any SQL to see if it's still compatible with whatever database you're switching to. But in a lot of cases, things are largely compatible, and just a few tweaks here or there are needed. So you can definitely do that. And if you wanted to make something that was completely generic, you could certainly do that. Rather than having a specific database type here for the property, you would just use database, the superclass for all the database classes. And then that, in combination with casting and some other clever app design, you could essentially just have your code automatically switch depending on whatever database you tell it it's connecting to. That would be quite a bit more work to set up, though, and may not be entirely worth all the effort, as most people do not switch databases. Once one is picked, that is often the one that people stick with. All right, I'm just scanning here, but I think that was the last question I'll be able to answer. Yes, looks like it. And perfect, right on time. All right, well, I hope this was useful to people. Remember to sign up for, not really part 2, but a continuation of this webinar. Bring that URL back up here. Get to the right page. So you can go to the webinars page on the Xojo website and sign up for that. That's coming up, I think it's on the 22nd. So it's like 3 weeks from now. Gives me plenty of time to prepare. And then this is just the address to the Chinook database, which you might want to grab. So I hope this was all useful to everyone. Thank you for attending. Have a great day.